Hello viewers, this is the third part of aldehyde, ketone and carboxylic acid. In the second video, we have seen the nomenclature of aldehyde and carboxylic acid. Now in this video, we are going to see the nomenclature of ketone. Okay, one by one we will see the examples, but before that I want to tell you the rules how to write the triple name and the IUPAC name. Now to writing the triple name of ketone, there are two rules, just simple rules these are. First one, whenever you are writing the triple name of ketone, alkyl group is taken as a prefix and whole ketone word it is taken as a suffix. For example, suppose methyl C double bond O CH3. We want to write it this name. Then here two methyl groups are there, so the name is dimethyl ketone. Okay, one more example we will see. We will take a different methyl group CH2 CH3 and here the CH3 will remain as it is, the same CH3 I will take. Now this is the simple or symmetrical ketone and this is the example of unsymmetrical or mixed ketone. Now this this alkyl group is ethyl and this is methyl. So alphabetical E comes first, so ethyl methyl ketone. What I have said it the first rule, ketone word is used as it is in the common name and alkyl group is shown as a prefix. The second rule is whenever the substituent is attached on the carbon chain, then it is shown by the alpha, beta and gamma and so on. Suppose this is the example. Okay, this carbonyl carbon atom, the next carbon atom is this one, it is considered as alpha carbon atom and this one is the beta carbon atom. And suppose the ring is extended, two more carbon atoms are attached, then it will be gamma and delta and so on. It's in common name system, the Greek letters are used. The name of this is alpha chloro. Two carbon atoms are there, so it is alpha chloroethyl. This is methyl ketone. This is about the triple name system. Now we will see the IUPAC name system. Now let us see IUPAC names of ketone. Before that, first of all we will see the rules how to write the IUPAC name of ketone. The first rule is the parent root word alkane, in that E is replaced with ONE. Okay, and the name will be alkanone. For example, suppose 3 carbon atoms are there, then the name is propane. From propane, E is replaced with the ONE, then the name is propanone. Second rule, when 2 carbonyl groups of ketone are attached, in that example, the E is retained as it is from the alkane and the suffix dione, dione is added in the name of parent ketone. Third rule is whenever the substituent is attached, then it is shown by the proper number as 1, 2, 3 likewise. Now here we have to use the numbering system 1, 2, 3. From which side the ketonic carbonyl group is near, from that side we have to start to give the number. Then from this side it will be near, that is on second position. Suppose we have given number from this position, this side, then it will be third. So always we have to select the number from which side the ketonic carbonyl group is near. This is what the third rule. Fourth rule is let us see the fourth rule, which is related to the polyfunctional compound. Now polyfunctional compound means one or more functional group is given. C double bond O, CH2, CHO and CH3. Let's see this example. Now in this example, two functional groups are there, that is CHO, it is aldehyde, and C double bond O, it is ketone. Now in this polyfunctional compound, the higher priority functional group is always lower number, that is 1, means we have to start to give the number from higher priority functional group 1, 2, 3, 4. Always remember that the aldehydic and carboxylic functional group, it is always on the terminal carbon atom. If it is 2 or 1, it is always on the terminal carbon atom, and the ketonic carbonyl group, it is in between the ring. Now in such type of example, the C double bond O ketonic functional group is written as oxo. Okay, the word oxo is used when polyfunctional compound is given. Now oxo, it is on the third carbon atom, so 3 oxo, 4 carbon atoms are there, so it is butane. E is replaced by aldehyde group is given, so it is Al. 3 oxo butanol. One more rule is given, that is fifth one. When alicyclic or acyclic ring is given, at that time the ketonic group is always numbered as 1. Now see this example. In this example, this is 1, 2, 3 and 4. Then the name is 4-methyl 2-chloro cyclohexanone. Now in this rule we will see one more sub rule, 4-methyl 3-chlorocyclohexanone, sorry, 4-methyl 2-chlorocyclohexanone. It is not a correct name. Why? Because we have to write the substituent always in the alphabetical order. So C comes first, so the name is 2-chloro 4-methyl cyclohexanone. This is the correct IUPAC name of this example. Now we will see the examples on this. Now let us see one by one examples of ketone. We will write together the travel name and IUPAC name. First example is this is the first example of ketone, CH3 C double bond O CH3. According to the common name system, the name is dimethyl ketone, or one more name is there which is accepted by the IUPAC, that is acetone, and this name is commonly used, acetone. This what the common name. Now IUPAC name of this, we have to give the number 1, 2, 3. The IUPAC name is propan. On which carbon atom carbonyl group is given? On second carbon atom, so the propan 2 on or propanone. Second is CH3 CH2 C double bond O CH3. Its common name is ethyl methyl ketone, and the IUPAC name is 1, 2, 3, 4. The name is 4 carbon atoms are there, so the root word is butan 2 ol. Next example, CH3, CH2, CH3, C double bond O, CH3, and the common name is methyl N-propyl ketone. Methyl N-propyl ketone, and the IUPAC name is 1, 2, 3, 4, 5. On second carbon atom, ketonic group is there. Because of 5 carbon atoms, we have to write it here, pentanone, pentan 2 on. Okay, and the correct name is pentan 2 on. Let us move forward. The next example. Fourth example is CH3, CH2, C double bond O, CH2, CH3. Now this is the example of simple ketone or symmetrical ketone, because either side of the carbonyl group, 2 alkyl groups are same. Then the name is, common name, diethyl ketone. And what about IUPAC name? We have to give the number to the carbon chain. 5 carbon atoms are there, so the root word is pentan. And the ketonic group on the third carbon atom, so it is pentan 3-one. Next one is now either side of carbonyl group, this is the N-propyl and this is the ethane, but ethane contains one more substituent, that is Br. So the name is, this is alpha carbon atom, this is beta carbon atom. So the name, common name is alpha bromo ethyl N-propyl ketone. And what about IUPAC name system? We have to give the number from which side carbonyl group is near. From this side it will be near 1, 2, 3, 4, 5 and 6. Now on second carbon atom, bromine is given, so we have to take it that first. 2-bromo hexane 3-one. Done. Let us see the sixth example. This example I have given the number from this side. Why? Because the carbonyl or ketonic group is near from this side. Now common name of this example is acetyl oxide, and we will write the IUPAC name. Now here on fourth carbon atom, methyl group is given, so 4-methyl pentan 2-on. This is the IUPAC name. Next one, seventh one, here 2 ketonic groups are given. Suppose I will give the number from this side, 1, 2, 3, 4, 5 and this one is 6. And I will give number from this side again, 1, 2, 3, 4, 5 and 6. Anyhow 6 carbon atoms are there, but suppose we have considered the left hand side numbering, this carbonyl groups got the second position and this will get the fourth position. So always we have to consider for the lower numbers. So this is the wrong numbering system, we have considered this one. Okay, then the name is hexane. What I have said it, when 2 carbonyl groups are given, then E retain as it is, then the hexane 2,4-dione. This is the correct name. Next one, when the polyfunctional compound, here 2 functional groups are given, one is the aldehyde, another one is the ketone. Then aldehyde having highest priority than the ketone. So the number always 1, 2, 3 and fourth one. Then the name, likewise examples, the ketonic group is always shown as the oxo. So 3-oxo-butanol. This is the correct IUPAC name. Now we will see next example. Ninth one example. This is the simple ketone. Why simple ketone? Either side of carbonyl group, same aryl group is attached. Then the name is diphenyl ketone. This is the common name, and the IUPAC name is benzophenone. Actually, this benzophenone is the common name, but IUPAC accepted this as a IUPAC name. Why? Because it is easy to use it. Next one, the 10th one example we will see. This is the example of mixed or unsymmetrical ketone, because either side of carbonyl group different groups are attached. Here alkyl group and this one is the aryl group, and this is the acetophenone. Now this acetophenone is the common name, and this is also accepted by the IUPAC, and this is the IUPAC name, and the common name is methyl benzyl or methyl phenyl ketone. And the last one, we have seen this example when alicyclic hydrocarbon is given. At that time always the carbonyl group is first, second, third and fourth. Then the name is 2-chloro-4-methyl cyclohexanone. Likewise, we have completed the nomenclature of aldehyde, ketone and carboxylic acid.